Hello algebra students, this is an introduction video for our lesson on graphing linear inequalities. The first part of this and what's going to be an important skill for today's lesson is being able to graph equations. So this first part is a review. I encourage you pause this video now and graph the equation y equals 2x minus 3. It'll be good practice for what we're doing today. Got our equation all labeled with what we know. We know the y-intercept is -3, so I can put a point on my y-axis there. And then our slope is 2, which means our line rises 2 and runs 1. So from this purple point, I'm going to rise 2 boxes and run 1. And like we've done in the past, you can do a lot of points to see this is where our line would be. The final step would be just to draw a line through all of these points. Hopefully a straight line, and then that is our graph of this equation. So questions like, is 4, 5 a solution? You could identify if 4, 5 was a solution by substituting 4 for x and 5 for y into your equation, but if you have the graph, we've learned that any point that is on the line is a solution. So 4, 5 is this point right here, and because it's on the line, it is a solution. If you put 4 for x and 5 for y into your equation, it would say 2 times 4 minus 3 is 5, which is true. 2 times 4 is 8, and 8 minus 3 is indeed 5. This is what we've already learned. In today's lesson, we're talking about graphing inequalities, like y is greater than or equal to 2x minus 3. Now we've learned this sign right here means greater than or equal to. So this right here tells me we're talking about y is equal to 2x minus 3 or y is greater than 2x minus 3. It's talking about both of those situations. So since it's talking about the same equation we had above, when you go to graph inequalities, it's going to start very similar to what we've done with equations. When I go to graph this, I'm going to start at my y-intercept at -3, and then I'm going to use my slope of 2 to know that my line should rise 2 and run 1. So this first part is identical to what we did above. The difference is what comes after. This line right here just represents the equation, but we also need to show all of the solutions to y is greater than 2x minus 3. And the way we do that is by shading part of the graph. It's very similar to when we were talking about stuff on your number line, like x is greater than 2. We would shade all of the numbers greater than 2. It's similar to that, where we're coloring part of this graph. All of the solutions are on one side of the line. So it's going to be all of the points up here or all of the points down here. The way we figure out which side to shade is by checking one point to see if it's a solution. So for example, I'm going to pick any point not on the line. And my favorite one to do is 0, 0. If I put 0, 0 into this inequality, it's going to say 0 is greater than or equal to 2 times 0 minus 3, which when you do that math, 2 times 0 is 0, so you've got 0 is greater than -3. That's true. So that would tell me that this point 0, 0 is a solution, but also any point that's on that same side is a solution. That means every single point up here is a solution point, and we show that by coloring in all of those points, similar to when you colored it on the number line. This graph then says any point on the line is a solution, like we said up here with equations, but also any point in the shaded area is a solution. So once you have that graph, you can answer questions like this. Which points below are a solution to this inequality? Pause the video now and see if you can identify which points are solutions. The way we identify which points are solutions is you find each of these points on the graph, and we've said if it's in the shaded area or if it's on this solid line right here representing the equation, it will be a solution point. So for example, 4, 5, 4, 5, this point right here, it's on our line, and so it is a solution. The point 3, 0, 3, 0 is right here. It's not in the shaded area, it's not on the line, so it's not a solution. -3, 2, -3, 2 is right here. It's in the shaded area, so it is a solution. And then 1, -4, 1, -4. It's not in the shaded area, so it's not a solution. Points like 4 or 5, if I substitute them into this inequality, it's the same math we did up here. It would give me 5 is greater than or equal to 5, which is true, but also points like -3, 2. If I substitute that into this inequality, it would say 2 is greater than or equal to 2 times -3 minus 3. When you do that math, you get -6 minus 3, which equals -9. 2 is greater than -9, which is why this is true. But we love the graph because it saves you from having to do all of this math. You're just looking on the graph to see is it in the shaded area or on the solid line. In today's lesson, we're going to look at more examples of how to graph inequalities like this, and also some stories where this could help you understand the story. Thanks so much for watching.